Hello, math students, and welcome back to Module 11, Geometry, and this is Lesson 15 called Geometry Applied to Proportional Relationships. Our goal for today we will learn how geometrical shapes can be related to proportional relationships. The question that I want you to think about in this lesson is, what is another name for the constant when working with geometry in proportional relationships? Now, this is going to make you stretch your brains because we have not talked about proportional relationships for a very, very, very long time. But one of the things that we did talk about when we were working with proportional relationships is y equals mx. Y equals mx. And so I want you to think about y equals mx, and I want you to remember what that means. If you think back to a long time ago where we used that 6 squared table, and in the first one you had a ratio table, and in the second one you were supposed to figure out what was the rule that you used to get the x and the y out of the ratio table, and then you had to find the unit rate, and then you had to graph it, and then you had to decide if the graph was proportional because it had a straight line, it had a constant, and it went through the origin, and then finally you were able to write an equation that looked very much like this, being that y happens when you take the constant times x, or the unit rate times x. Hopefully that's jogging your memory and remembering proportional relationships. So the reason why I'm doing that little memory jot is because you're going to have to apply that to our geometry lesson today. So let's go to the things to remember. Scale drawings are used to represent actual items that are too large to fit on a piece of paper. They could also be too small to see without a magnifying glass. And so scale drawings are drawings that help us see something. Okay? Geometrical figures are often used in scale drawings. Scale drawings are created by applying a scale factor to the original sized item. That's a very important concept right there. Scale drawings are used by applying a scale factor to the original sized items. A scale factor is a rate multiplied by the dimensions to create the drawing of the original. The rate can be in a fraction or a percent. And so you have learned about rates. Sometimes they're called unit rates, and you do know that they can be represented by fractions or by percents because we've been working with those a lot. A reduction is a scale drawing that is smaller than the original. Reduction, smaller, that makes sense. Reduction means that you make it smaller, okay? An enlargement is a scale drawing that is larger than the original. So you're blowing it up, you're making it bigger so it's easier to see. So an enlargement is where you make it a larger version of the original, okay? And then we have an equation, and an equation is used to determine a scale drawing is, an equation used to determine scale drawing is scale drawing equals scale factor times original. Wait a minute, let's say that again. Scale drawing equals scale factor times original. SD equals R times O. So scale drawing, SD, scale factor, what we use, and I don't have any reason why, I don't know why, if you guys want to Google it and figure it out, why they call a scale factor the R factor, but that tells you what the size change is going to happen, and then O stands for original. So SD equals R times O. Now, I want to flash back up here really quickly, and I want you to compare these two equations. This equation is what we used when we were working solely with proportional relationships, y equals mx. Well, when we're working with geometry and proportional relationships, scale drawing is scale factor times the original. Interesting. So this little guy right here is actually very, very important because that little guy is what you already learned about proportional relationships. And that little guy right there is the same thing as your m. And if you remember what your m was your unit rate. So this is also your constant. So remember we talked about it having many names. Unit rate, constant, and now we can also add to it scale factor. The scale factor is the constant amount that you're changing the original by. And remember that a reduction is smaller than the original, and the enlargement is larger than the original. Okay, so that's kind of interesting. So one way that we can think about this is by looking at this snowman scale drawing right here. So let's say we have 3 different circles or 3 different piles of snow. And if I tell you right here that this is the original, okay, so this circle or this pile of snow is the original, okay, then what would this pile of snow right here be? That pile of snow would be a reduction. And how do you know that it is a reduction? Well, the way we know is this is the original size. This one looks smaller. So that is a reduction. So when you have the original drawing and the drawing looks smaller, then you know it's a reduction. Well, then if we go back to the original, what would this one be then? If this one's the original, this one's a reduction, what does this one right here have to be? If you said an enlargement, you are correct, because this is an enlargement. Okay? And so original means the original size. Is there a percent that you have been working with or that you have learned or Mrs. Nelson has drilled into your head for a very, very long time that represents an original? Think about your double number line, okay? Yes, the answer is 100%. So when you have the whole or the original, it's 100%. If we go up here and we read a reduction is a scale drawing that is smaller than the original, then what kind of percent would a reduction have to be? And the answer to that question is anything less than, right, 100%. So that's a reduction, okay? An enlargement, however, is anything that is greater than 100%. And the reason we know that is because the only way that you can make this one bigger than the original is that the scale factor has to be bigger than the original. And if the original is 100%, then you know the scale factor has to be greater than that, okay? So it's very, very important that you start thinking about this, because in our next few lessons, we're going to show you how to apply it and make sure that you understand. So basically, when you're working with geometry and you're trying to use the proportional relationships, you have to remember that a scale factor either reduces the original size or it enlarges the original size. And you need to know the difference between those two types. Okay, so going back to our goal, today we will learn how geometrical shapes can be related to proportional relationships. Scale drawing equals scale factor times original. Y equals mx, so the y equals a unit rate times the x value, so you can see how they're related that way. What is another name for constant when you're working with geometry and proportional relationships? We talked about that, and I even highlighted it in green. So another name for constant when you're working with geometry is scale factor. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.